Welcome! In this series of short videos, we will give an introduction to those who have never used PowerBasic before, or even considered taking up programming. Today we will look at one of the many things that both the Windows operating system and PowerBasic do to make your life easier as a programmer: memory management. So what is memory management? Memory management is a mechanism to allow the resources of the computer, both actual memory and disk, to be best used to enable multiple applications to run efficiently. This does involve moving data blocks around in memory to make the best use of that memory for the applications which are currently running. Applications which are idling can be temporarily swapped out, that is, written to disk, to free up memory for other processes that are still active. Operating systems do all this magic in the background. In addition, an application may start off by using a modest amount of memory, but later request more from the operating system to perform some intensive or large task. So does PowerBasic have any inbuilt memory commands? Global Mem. Allocate or release a block of memory. You can allocate, free up, lock, determine the size of, and unlock blocks of memory. Memory. You can copy from source to destination, swap a source and a destination, and fill a destination. Peek and poke. These are traditional low-level commands to both read from and write to memory locations. Use of these commands will be covered in a later video. So, do I need to use these commands when I write an application? The majority of your applications may not need you to use these commands. However, if you are writing a niche application that needs to be exceptionally efficient or fast, it's good to know that PowerBasic has commands that will assist you. So what's happening in the background of my application? Let us take a simple scenario involving strings. If we declare a simple string variable called strdata, we are requesting two things. Firstly, that an area of memory is allocated to hold the name and the type of the variable. Secondly, that an area of memory is allocated to hold the value of that variable, which is currently a zero-length string. Let's look at a simplified description of how this could be held in memory. The length of the name of the variable could be short or long, so some kind of end of name marker would be needed. So let's use a null character here. We'll use the character S to indicate that it's a string. And finally, a pointer to where in memory the value actually lies. As this is a dynamic string, we need to know how long it is or where the string data ends. If we then populate the variable with some data, then that information is then written to memory. Later in your application, you can retrieve that information and PowerBasic will return the data associated with the variable. But what if the content of the variable needs to change? The variable may now need to store more characters or less. As you will be storing a lot of variables, there may not be room in the current memory location to store additional characters. How could this be handled? The new data is copied to a new location in memory. The pointer to this new memory location is updated for the variable, and the old location is freed up for other use. As you will guess, this will lead to fragmentation of memory, with little areas of memory being either too small or scattered to contain new variable data. This is taken care of by a background process that defragments memory and moves it around to make the best use of the memory that is available. Remember that this happens for all variables in your application and every application or process happening on your computer. It's a testament to those that have written operating systems and programming applications that this works so well, and that most of the time we, as developers, don't need to worry about where and how our data is being stored. That's it for today. Thank you for watching.